As we start this lesson on mutually exclusive events, I want to remind you that the probability that something will happen is a comparison of two numbers, the number of ways that you hope it happens, that is favorable outcomes, compared to the number of ways that it possibly can happen. Now that's a pretty simple definition of probability. It can get a little more complex than that, and there are different kinds of events that come in different categories. And one category of events are events that are mutually exclusive, and there's a pretty easy definition of that. They're events that can't happen at the same time. The word mutually exclusive kind of implies that, because mutual means together and exclusive means not together. So there's things that we're thinking about as being together, but they really can't be together, so they are mutually exclusive. If one's present, the other's not. For example, you roll a die just one time, and you get both a 1 and a 6 on one roll. It can't happen. You can't get those together. If you get a 1, you're not going to get a 6. If you get a 6, you're not going to get a 1, because you roll a die, it only happens one way. Or if you toss a coin and get both heads and tails, you can't. You just can't connect them with the word and. They can't occur together. Or if you pick a number between 1 and 10, and you want to know what's the probability that your number is prime and composite. But those two things are mutually exclusive. By definition, prime numbers are not composite, and composite numbers are not prime. So they can't occur together. Now you could say, what's the probability that I roll a die and get a 1 or a 6? And there's a way that you can calculate that. Or you could say, if I toss a coin, what's the probability that I get a heads or a tails? And you probably know intuitively that that is 100%. You're going to get one or the other. By the way, I forgot to tell you last time, if the probability, if something is certain to happen, the probability is 1, or 100%. You can express probabilities as a number between 0 and 1, or as 100%, or a number between 0 and 100%. If something is not going to happen with a certainty, it cannot happen, it's impossible, there is a 0% probability of it happening, or the probability of it happening is 0. So you can express probability as a range of numbers between 0 and 1, including 0 and 1, or between 0%, including 0%, and 100%. Because 100% means 1, same idea. Now what you can do is say that if these two events, A and B, like rolling a die and getting a 1 and getting a 6, if they are mutually exclusive, the probability of getting a 1 or a 6, which is how you read this, probability of A or B, event A or B, is equal to the probability that they're separate probabilities added together. The probability of event A, which would be getting a 1, plus the probability of event 2 getting a 6, and those are both 1/6. So in this case, the probability of getting a 1 or a 6, since they can't happen together, is 1/6 plus 1/6, or 2/6, which equals 1/3. And the probability when you toss a coin that you get a heads or tails, because you really can't connect these events with the word and, because that means they could happen together, and they can't happen together because they're mutually exclusive. You can connect these events with the word or, because one or the other could happen, but not both together. So the probability of getting, probability of heads or tails would equal the probability of heads plus the probability of getting tails, which is a half plus a half, which is 1. So that's how you would figure that out. Then I want to do a couple of experiments with cards. And I have some Uno cards here. I have a blue 2, and a red 3, and a red 4, a yellow 5, and a yellow 6. So I could pose different kinds of problems. What's the probability that I get a 2, or a 3, or a 4? So I can think about what's the probability you get a 2, which is 1 out of 6. 1 out of 5, sorry. The probability that I get a 3, there's only one card that's 3, so that's 1 out of 5. Now the probability that I get a 4, which is 1 out of 5 also. So the probability of getting a 2, 3, or 4 And this is sort of the math with it, but it's really easy to see it when you just look at the list. A 2, 3, or 4, there's 3 things that satisfy the condition, 3 out of 5. But I want you to really kind of know how the formula works too. So that would be 3/5. What's the probability of getting yellow or red? The probability of yellow or red. So there's 2 yellows, 2 out of 5, so that would be 2/5. Red is 2/5. So that would equal 4/5. Now let me give you an event that is not mutually exclusive and see if you can figure out why. What's the probability of getting a red or a 4? And can you think why that's not mutually exclusive events? Because you can get a red and a 4 that are together. They're not mutually exclusive. So that is a more complicated kind of problem. It's actually, when you see this space, it's not hard to figure out that this would meet the condition, and so would this. But it's not, you can't say there's 1 4 and there's 2 reds, so it's 3 out of 5. There's 1 card that's red, but it's not a 4, so that's one thing that meets the condition. This other card separately, it happens to be both red and a 4 meets it, so the probability of getting red or 4 would be 2 out of 5. So it's not quite as simple as you might think it would be. Or we could say, what's the probability of getting a card that's not red? And that would be 3 out of 5, because we can't include these 2. Or what's the probability of getting a card with a prime number?
Hi, 7th graders. How are you?
Actually, they're 8th graders, so...
Hi, 8th graders. How are you?
So then you would say, I Mr. Billy made me forget the question, so I'll start over again. So probably getting, well, you figure out the answer to the question. You're pretty smart. So we'll close with that. Those are events that are mutually exclusive. Remember, they can't occur at the same time, so you have to kind of think critically. And it's just the sum, basically it's the sum of their separate probabilities.